Hello everyone, welcome back to Into the Controlverse. In the previous chapter, we discussed why control engineer is needed. Today, we will look at the two most fundamental ideas in control engineering, feedforward and feedback. Almost every control system you'll see in industry is built on one or both of these ideas. Once you understand them, many different control methods will start to make sense. So, let's begin. Let's quickly review the previous chapter. Every control problem has the same basic structure. We have a target. We apply some input to the system. The system produces an output. However, disturbances and uncertainties make the output different from what we wanted. That difference is called the error. The purpose of control is simple. Reduce this error as much as possible. So the question becomes, how can we reduce the error? So there are two fundamental answers. The first one is feedforward. The second one is feedback. Although they sound similar, their ideas are actually quite different. So let's first look at feedforward. Feedforward means taking action before the error appears. Instead of waiting for something to go wrong, we predict what is going to happen and prepare for it in advance. Imagine you are driving toward a steep hill. You already know climbing the hill will slow the vehicle down. So before reaching the hill, you press the gas pedal a little more. You haven't lost speed yet, but you are already preparing for the disturbance. That is feedforward control. It uses information about the future or information about disturbances to prevent errors from happening. So feedforward appears in many engineering systems. For example, cruise control can increase engine torque before climbing a hill if the road grade is known. Active noise control predicts incoming noise and generates an opposite sound. Hybrid vehicles estimate future torque demand and prepare engine and motor output. The common idea is always the same. Predict first, act first. Then, feedback takes a different approach. Instead of predicting, it measures what actually happened. Suppose you want to drive at 80 kilometers per hour. You notice the speed has dropped to 70 kph. Now you press the accelerator, gas pedal, some more. Then you observed the error, compared it with the target, and corrected it. This is feedback control. Feedback always reacts after the error appears. Now, let's compare them. Feedforward is fast because it acts before the disturbance causes an error. Its response can be almost immediate. However, feedforward requires a good model. So if the prediction is wrong, the control action may also be wrong. Feedback is different. It doesn't need to predict perfectly. It simply measures what actually happened and corrects it. This makes feedback much more robust against uncertainty. The drawback is that the error has to occur first, so there is always some delay before correction. Neither approach is perfect. Each has strengths and weakness. Next, I'd like to show why real engineering systems usually combine both. Imagine driving toward a hill. Feedforward notices the hill ahead and increases the throttle before reaching it. Even so, the road may be steeper than expected, or the vehicle may be heavier than expected, or wind conditions may change, so some speed error still appears. Then, feedback measures that remaining error and adjusts the throttle again until the target speed is recovered. This combination gives us the best of both worlds. Feedforward handles what we expected, feedback handles what we didn't expect. That is why you'll find both methods together in many rare products. Now, we have learned two basic ways to control a system. So we are ready to move on. In the next chapter, we will look at several representative control design methods, including PID, LQ optimal control, H infinity control, and model predictive control. But rather than diving deeply into the mathematics, we'll focus on the main idea behind each method, when engineers use them, and the strengths and limitations of each approach. Okay, see you in the next chapter. Bye.